let's say you have 8 pound. Let's work with pounds now a little bit. 8 pound, and then let's say the static friction here the static friction is 0.3, the kinetic friction is 0.2. Somebody's trying to move it here. And let's ask some questions about that. Okay, we can say part A here. If the force F is equal to 5 pounds, will the block move? If yes, what is its acceleration? If no, then what is the friction force? What is the magnitude of the friction force that is preventing it from moving? B, what is the minimum force F needed to make it move? C, if you pull with a force 1 pound more than that, what is its acceleration? D, what is the force needed to make it move at constant velocity once it has moved? What is F needed to make it move at constant V once it has moved? And what is A if F is 1 pound more than that? I know the problem seemed like such an easy problem from the picture, and I made it so hard. Why did you have to go ruin the problem? Ask so many questions about the easy looking problem here. Well, because this thing, even though it's easy looking, it acts as a generic problem from which we can do harder problems, right? But by analyzing here the easy problem, we can answer a bunch of questions. Let's see here. What is A if F is 1 pound? I should write here if F is 1 pound more than that. Okay. So when we're solving this, we could, I guess we could even start with part B, because B is saying what is F needed to make it move. Okay. So here the normal force. The weight of the object is we already know is 8 pounds. And the static friction force, well, the maximum that static friction can be is mu Sn. That doesn't mean that it's always equal to mu Sn, but the maximum it can be is mu Sn. So N is equal to 8, right? That's pounds. And then Fs max is 0.3 times 8, right? So Fs max is 2.4 pounds. Okay, so what is F min to make it move? So if you have, if mu s is 0.3 times 8 is 2.4. So now we can answer part B. What is the minimum force you need to make it move? Well, as long as you can beat 2.4, right? As long as this can equal to the, this is Fs right here. So in part A, so, no, sorry, we're answering part B first. What is F min? So F min is equal to 2.4 pounds. As if you go a little more than 2.4, the thing will move. Okay? So now we can go back to part A. If F equals 5 pounds, will it move? Yeah. Okay, yes, it will move. And then what is its acceleration going to be? Yes, yeah, the answer is yes. And the acceleration is going to be 5 minus, let's see here. You're pulling with 5. So that means it's going to move if you pull with 5. So what is the friction force going to be now? You have to remember that if the thing is moving, static friction force has ended its life. It's dead. It's done its job. You have kinetic friction force takes over now. So 0.2 times 8 pounds. That's the friction force. Fk. Which is 1.6 pounds. So now you do 5 minus 1.6 equals ma. So in other words, we're answering the question, if the thing is moving, what is its acceleration? So 5 minus 1.6, so we have here 3.4. What is its mass? It's, remember, it's in slugs. It's 8 divided by 32. So quarter slugs. So the acceleration is going to be what? 1/4, it's going to be 13.6. And it's feet per second squared. Okay? Now, what if the force that you had been pulling with was, let's say, 2 pounds? Okay? What if F was 2 pounds? Would it move? No. So the answer would be no. Then what would be the answer to that question? No. And what is Fs? Is Fs 2.4? The answer is Fs is 2. It doesn't need to equal its maximum.